Hi, I'm Jana Peterson, and today on Built to Last, we're going to take a look back at how carpenters construct a residential home, from the foundation to the shell of the home, to the doors and exterior finish, and finally the flooring on the inside. Plus, we'll talk with industry decision makers about Generation Green and learn how this new innovation will benefit the future of the construction industry.
Built to Last is sponsored by Unico Incorporated, manufacturers of the small duct high velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.
Everything starts with the foundation and builds up from there. It's a critical step in the construction process that provides the needed support for the framing and roofing to take place. Constructing the shell of the home is the most time-sensitive stage, but it must be done right in order for the rest of the house to go well. Now, the carpenters who work on the shell of the home need to deal with the elements year-round and stay safe from dangers like heavy loads and high roofs.
All buildings start with the preparation of the ground at the site of construction. Carpenters will construct the forms that concrete will be poured into, but the operating engineers will dig a hole to the depth required for the basement. It may take a crew of 3 about 4 hours to form the footings. The foreman then makes a call to a ready-mix plant that will deliver the concrete that will be poured into the footings. Constructing the walls of a foundation follows the same basic process as building the footings. Forms are erected to hold the concrete as it gets poured. Then after drying, they're removed. There are various systems of these forms, from just scratch plywood to styrofoam insulated ones. These carpenters are using reusable forms that can be used again on different projects. With wall forms, ties are inserted to hold the form together to support the pressure of the concrete pushing against them. The concrete takes about 28 days to cure, meaning it has reached its full strength. Finally, the floor is poured and the foundation is complete. But the work of the carpenter has just begun. Framing is the skeleton of a building. It's a supportive structure that allows loads to be transferred from one to another, from the ridgepole to the foundation. This supportive skeleton allows for door, window, and stairway openings, as well as roof and balconies. After all mechanical components, exterior doors and windows, roofing, electrical, plumbing, and insulation have been installed, the structure will usually be covered by drywall on the interior and covered by siding or other materials on the exterior, which is exposed to the weather. Carpenters build from the ground up. Starting with the foundation, floors and walls transfer all the loads from the upper sections down to the foundation. Different framing techniques, along with strict building code compliance, are followed. Rules have been passed on from generation to generation that applies to all buildings, from high-rises to houses. To square, level, and plumb a building is the universal language and is understood by carpenters all around the world. The old school way of doing things was using hand saws for cross-cutting and ripping lumber. Brace and bits were used for drilling holes. For measuring, a carpenter would use a 6-foot folding rule. Cordless electric saws, drills, nail guns, retractable tape measures, computers, and laser-guided miter saws are in the toolbox of today. What used to take months or longer with many men is done today with only a few and in days instead of weeks. The roofing products arrive on site at a predetermined time and are offloaded to the roof. This truck has a boom that lifts each pallet of shingles, and the carpenters place them in strategic areas of the roof. In the past, the carpenters would carry the shingles up the ladder on their shoulders, called humping. Nowadays, conveyors, lulls, or delivery trucks with booms make short work of loading roofing materials. We've all seen icicles hanging over gutters and roof eaves, but don't pay much attention to them because of the season. To the trained carpenter, this could be an ice dam and could mean an extreme situation that can cause the roofing system to fail with severe consequences. The first line of defense is an ice and water shield made from a rubber membrane with an adhesive back with a very smooth front side. This acts as a gasket to seal and prevent ice buildup. If correctly installed, it can be a deterrent to ice dams. Starter shingles are installed along the eaves of the roof line, allowing for just the right amount of overhang. To securely fasten the shingles, a coil nail gun is used. The nail gun is a high-speed tool that uses compressed air to power it. Nail guns have greatly increased the average speed of the carpenter compared to using a roofing hatchet and rolling nails by hand.
Once the shell of the home is complete, it's time for the functional openings, such as the windows and doors, to be installed. Today, windows are an industry all their own, and it takes a trained and qualified carpenter to make sure they're installed properly to get the manufacturer's warranty. The siding that goes onto a home provides protection from the elements as well as the whole look of the home. But not all siding is created equal. In fact, different techniques need to be applied for different types of siding.
Well, there's a variety of reasons why you'd want to have a house wrap professionally installed on your home. But the three major is, one is to keep your wall system dry, to keep rain or any kind of bulk water from getting behind your siding and getting into your wall system. Second is to keep air infiltration. You don't want air currents coming through your walls. It creates an uncomfortable environment in the house. And third is energy efficiency. Having a house wrap helps your insulation to perform at its highest rating. Think of it this way. If you were outside on a cold day, 40 degrees let's say, but there was no wind and you had a nice sweatshirt on, you'd feel pretty comfortable. However, if the wind kicked up, pretty soon that sweatshirt isn't working as well. And then, if it started to rain, now you're wet, the wind is blowing and it's 40 degrees, you're cold. A house wrap works a lot like a windbreaker. It stops the air from blowing onto your insulation, robbing of its R value. It stops the wall system from getting wet and allows you to stay comfortable.
The first step of installation is cutting the exterior barrier. Unlike what we've done in the past, is actually cut a big X in here. Now we've actually doing our eye cut. You start at the bottom, cut all the way across. This tape at the bottom actually covers your rough opening and actually protects your rough opening from any sort of water infiltration. The first piece of tape starts 6 inches up on either side and overlaps the exterior by 1 inch. The next step is taking 2 shims. Shims are needed at the sill for a water collection place to make sure the window is level and to allow for the water to evaporate towards the exterior. Now you're ready to install the window. The fins actually get pulled out to 90 degrees. These fins are actually what gets attached to your sheathing. Once the window is installed, you're going to put one screw or nail up on the top right corner, and then you're going to check for square. Square is the most important thing when it comes to window for installation because of operation. Then you cut 2 more pieces of tape, which is going to adhere to the window fin, then adhere to your exterior barrier. You're actually integrating the window now into your exterior system. The next step is the interior sealant, which is a low expansion for windows and doors interior foam. Once you have put your interior sealant on all 4 sides of the window, your installation is complete.
Steel door will hold better into the up with the weather. It's not going to expand and contract like the wood will. If it's exposed to both elements in the winter time, when the forced heat's in, it dries up that and it shrinks it up, and you're going to have leaks in the door. Where with the steel secure insulated door, you don't have that. They've got a threshold on it, to keep any wind from coming through or weather on the bottom, so the door can get sealed up. Well, for how this door's coming out, we're tighter at the bottom. We've got a bigger gap up top. Once the door's set in the jamb, we're gonna have to do some shimming to correct it. It's basically some cedar shims that we're just using because they're easy to cut, they maintain. When we're going to shim up against the jamb by each hinge, so we're going to make that tight back to our stud cripple, so the door can't move from that point. So as long as it's plumb and true, it's going to stay there. Well, when we're shimming these doors, we want to go with when you look at the hinge, once you open up the door, there's going to be 2 basic rolls of screws. You want to take the one closest to the outside edge of the door, because that's going to give you the fullest into your jamb when you run a longer screw through. So we'll pull one of these short screws out, and we're going to replace it with a 2.5-inch screw that is going to be able to secure it to the actual stud cripple framing of the house. After we install it, the painter will, he'll have to paint the jamb, the door itself. At that point, the hardware that's going to be on it, the door handles and stuff, will be installed.
Moves to a cooling bath where the temperature of the panel drops very quickly, setting the final shape. Then the nail slots are punched and the stud finder graphics are added. Finally, the panel is cut to length, inspected, packaged, and moved to a warehouse where it is staged for shipping. Injection molding is another process of making vinyl siding that offers more detailed impressions to make the vinyl look like authentic cedar shake, with its sharp edges and random grain that again look like real cedar shake. Injection molding starts off the same way as the extrusion process with the mixing of the raw materials, but then the resin is thrown into a hopper where the pigment is added. Then, from the hopper, the pellets of the compound drop into a large machine where the pellets form a solid bed. This bed of resin is pushed through the barrel of the equipment where a screw.
With the house finally coming together, it's time to take a look at the interior now. Drywall needs to be installed to not only hide the mechanical components of the home, but also to provide a paintable surface for finishing. Plus, the floors need to be covered to provide long-lasting durability. Today, new products are being created that offer different installation options throughout the home, and carpenters are trained to know how to properly install each one of these new materials to make sure that your investments last as long as possible.
The interior surfaces of a building have to be both practical and aesthetically pleasing. Ceilings conceal the upper part of a room from a floor or roof assembly and can add great aesthetic value. There are many classifications of ceilings, such as a dropped ceiling, where the finished structure hangs anywhere from several inches to several feet underneath the structure above it. It can be used to lower the ceiling height or for more practical purposes, like providing a space to run heating and air conditioning vents. A barrel ceiling, where the surface is curved like the inside of a barrel, can be used for aesthetic or acoustical reasons. And a coffered ceiling is made up of a grid of recessed panels. In common residential settings, straight drywall is often used in place of a decorative ceiling. Drywall is the term used for interior walls made from gypsum, a common soft mineral that's pressed between two thick sheets of paper. Since the 1950s, it's taken over lath and plaster as the major form of interior finishing. Drywall is more economical and efficient and can be made into many varieties with different properties, such as fire retardation and resistance to mold. It comes in different thicknesses for different applications, which is determined by local building codes. Drywall is installed vertically in commercial applications and horizontally in residential applications. In years past, drywall was installed using drywall nails, which over time backed out, leaving a blemish on the wall. Now, drywallers use drywall screws, which won't back out, leaving a beautiful and smooth, blemish-free finish.
There's a lot of little things to consider, you know. You just can't look at the aesthetics of it. You have to look at the functionality, how it's going to perform in the field, how it's going to be maintained, so on and so forth. Well, cost comes into it. Usually that always comes into it is cost, okay? But what's important also is it new construction? Is it existing structure? You have to look at the variables like, you know, sustainability. Is it going to be, you know, green? That's a big thing today. Floor conditions. You have to pay attention to that. There's moisture issues and stuff on new construction, so you want to be aware and you want to test the flooring to make sure that you're right at the relative humidity and moisture and you don't have any problems that way. And then, you know, how is the floor going to be maintained? Who's going to maintain it? Things of that nature.
This is an assisted living facility for elderly people and rehab. What we have on this project is there's 9 or 10 different luxury vinyl tiles installed in different areas of the facility, and the beauty salon is one type of product, reception area is another. Each floor, there's 3 floors, each floor has its own color code. It's the same carpeting, just different colors on each floor with the patterns in it. The room that we're standing in right now, it's vinyl plank. There's vinyl plank downstairs in the reception area. It's done with borders and mitering. It tests the skill of every installer that's out here. You have to know a variety of different type of applications. It's glue-down carpeting, glue-down vinyl, and the glue-down vinyl plank. There's no padding underneath this. It's designed that way for ease of traffic, walkers, wheelchairs, stuff like that. It's just a very well thought out project.
Today, new buildings are constructed with energy savings in mind, but that doesn't mean that an existing home can't be upgraded to improve its energy efficiency. A certified energy analyst will come in and perform a comprehensive energy diagnosis using a variety of tests to find out where the problems lie. Once that's done, they'll make suggestions on what measures need to be taken to improve your energy efficiency, so you, as the homeowner, can make those corrections with confidence.
Basically what we do is we provide our clients with a reasonable action plan for air tightening their home and making their home more energy efficient and comfortable. In the end, it's going to improve the value of the home and be a more durable product. A CEA, or a certified energy analyst, is going to come in with a series of equipment and perform a number of tests to the home, and then based on what they found in the home, provide recommendations to the homeowner so that they can then contact skilled tradespeople to fix the problems. They can do their energy improvements. Some of the pieces of that process are that we're looking for air leakage with a blower door test. We're using an infrared scanner often, if we can, to check for insulation in walls. and we're looking at the heating and cooling equipment, if it's the correct type, if it's safe. For example, when we'll usually do a combustion safety test of that heating equipment, meaning the water heater and the furnace. We'll also look at the distribution system for the heating and cooling system, which is typically ducts, but it sometimes can be a radiator system or pipes. And we'll also ask the homeowner about their utility bills. We like to look at the utility bills, and that's also the way they can compare before and after they've done their energy improvements. The blower door, which is probably the most important test that we do as energy raters in a home, is basically composed of a framework with a fabric that is air resistant. And inside of that fabric is a hole where we place a calibrated fan. The calibrated fan is then hooked up to a pressure gauge and a flow gauge, which allows us to measure the flow rate going through that fan, and also enables us to see how much pressure we're getting. Because basically what we're doing is the fan is pulling air from inside the house, pulling it to the outside. In the process, it's called depressurization. So we're depressurizing the house. And one of the reasons we do that is to find air leaks in the house. Because air leaks are kind of the little known secret that people don't really understand much about air leaks in homes. They understand insulation, they understand windows might leak and doors might leak, but they don't understand that there's some more complex places that there may be air leakage in the home that they are really important to seal. So the blower door test points us in that direction. We can use a blower door in conjunction with a smoke wand or smoke puffer, or in conjunction with an IR camera. Either one will work, and it shows us where the air leaks are. The other thing the blower door does is it gives us an absolute measurement for how leaky that home is. And we can compare a home in Chicago to a home in Miami or a home in London using these measurements, and they're comparable. You know, you can absolutely, you know, compare across homes and say how leaky a house is.
I'm really passionate about energy efficiency because you can essentially help the environment, save energy, and save money all at the same time. And you may wonder, why is saving energy or lowering my electric bill going to help the environment? And here's why. The connection is that in the US, and especially in the Midwest, most of our electricity comes from fossil fuel power plants. The problem with fossil fuels is, first of all, we only have so much of them, so they're going to run out one day, so we should conserve what we can. And second of all, most importantly, when we burn fossil fuels to create the electricity we use every day for lighting, for our TVs, for our video games, that electricity is being created in this power plant, which is actually spewing pollution into the air. So that's a connection I think a lot of people actually we don't make. We forget about it. We're so used to having a nice warm house in the winter with all these wonderful, you know, luxuries like appliances and lighting and all sorts of things, which are fantastic. But to really look deeply into how do we get that power? And a lot of times it does come from fossil fuel power plants.
Today, qualified and trained carpenters are valued more than ever as they make sure the all-new green innovation and technologies are properly installed and maintained. With me is Commissioner Manny Flores of the Illinois Commerce Commission. He's going to comment on community connectivity, neighborhood development, and green building initiatives. Great to see you, Manny.
Yes, thank you so much for having me.
You're welcome. Now, first of all, tell me a little bit about the future of construction and where things are going from here as we walk.
Well, you know, I really believe that the future of construction is based on the concept of sustainability, really taking a look at communities and their assets and connecting them, making sure that we're being thoughtful about how to access transportation, how to access grocery stores, how to access the things that make a good quality of life, parks, green space,
sure.
But also doing it in a way where we're being thoughtful about our construction and our building practices, making sure that we are thinking about energy efficiency, maximizing on energy efficiency, reusing buildings that are still viable, that are still strong, but that maybe could use some modification, some improvement. And then also taking a look at things like our educational system, job training, developing career paths. So it's a very comprehensive, very community, what I would call a community building approach. And I think what's really neat is the sustainability movement, environmental stewardship, clean energy, clean technology, all of that really contributes to this kind of new paradigm.
Sounds like it's all positive. Some great thoughts and ideas today, Manny. Thank you so much.
Thank you. Thank you.
And that's it for us today here on Built to Last. I hope to see you next time. Have a great week.
Visit the Built to Last website to learn about these topics and more.
Built to Last is sponsored by Unico Incorporated, manufacturers of the small duct high-velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.